All right, my friends, let's see how you did here. So for this problem, I'm going to go ahead and just copy the numerator. And then maybe just kind of off to the side, I'll factor the denominator. So for the denominator, x cubed minus 4x, step 1 is factor out the greatest common factor. And then you have a difference of 2 squares there and with x squared minus 4. So we could factor it as x plus 2 times x minus 2. So here is the complete factorization of the numerator. Now let's set up the form. So we're going to have a constant over the first linear factor plus a second constant over your second linear factor, and then a third constant over your last linear factor. Now note, if you did these terms in a different order, it should still work out. It's just like whatever I get for B, you might get for C, but then we put it in your own form and it ends up being the same answer when we're done anyway. So if your form looks pretty much like this, but just the terms are kind of in different order, then I wouldn't worry about it at all. Okay, now let's get common denominators. So a over x, in order to get this denominator, x cubed minus 4x, we would have to multiply that by the x plus 2 and the x minus 2, also known as x squared minus 4. Always keep your eye on the denominator you start out with to make sure that you're multiplying by the right thing. And then b over x plus 2, it would need to be multiplied by x and x minus 2, also known as being multiplied by x squared minus 2x. And then c over x minus 2, it would need to be multiplied by x and x plus 2, also known as x times, or x squared plus 2x. Like so. Okay, and then from there, we're just going to follow our algebra notes, distributing ax squared minus 4a plus, boom, boom, bx squared minus 2bx plus cx squared plus 2cx over, and then the new denominator would be what it was to start out with. So I'll just write as, you could write it however you want, I guess. I'll just write x times x plus 2 times x minus 2. There we go. Okay. Bring down your original fraction. Now this little step that I'm showing here probably seems like extra work to some. There are going to be some problems that'll come up when we're in Calc BC where if you don't have this habit of like making sure that you really did set the denominators equal to each other, you can kind of get burned. And so that's what this step is there for, is to kind of avoid that. Anyway, so now that I've won the denominator battle, let's kind of set the numerators equal to each other so we can win that battle too. Now on the right side, I do want to save myself a little work, so I'm going to group the x squared terms together and then factor the x squared out on the right side. Next, oops, I missed somebody. Bx squared is like, what about me? Oops. There we go. Okay, next I'm going to do that with the x terms. So let's see, I've got negative 2bx and 2cx. And I've got a constant term, which I could write plus negative 4a, but I'm just going to write negative 4a. There we go. Okay, now if I need these two expressions to equal each other, I would need the number of x squareds to equal each other. So that means I would need a plus b plus c to equal 5. I would need the number of x's to equal each other, which means I would need negative 2b plus 2c to equal negative 12. And I would need the constants to be the same. So I would need negative 4a to equal negative 12. So for this system of equations, I would definitely start with row 3 here and just divide by negative 4 and find out that a has to be 3. And then you could take that into row 1 and put the 3 in, and you'd find out that b plus c would have to equal, subtracting that 3 over would give you that b plus c has to be 2. And then row 2, my friends, notice that with row 2, you could easily divide both sides by 2. And it would say negative b plus c has to be -6. And then I'm just going to add these two rows together, and I'd find out that 2c has to be -4, which means c has to be -2. All right. Once I know c is -2, it's really easy to just kind of back substitute, I'd say right there, where you'd have b plus -2 or -2 has to equal 2. And so that means b has to be 4. Oh, man. All right, once we've got this, remember you're going to take your A, B, and C values and back substitute them into your form. So you know that B is 4. You know that C is -2. And you know that A is 3. So what's our conclusion? Our conclusion is, whoops, I started writing an integral. Sorry, wrong class. Is it 5x squared minus 12x minus 12 over x cubed minus 4x could be broken down into, A was 3, so 3 over x plus B was 4, so 4 over x plus 2, and C was -2, so -2 over x minus 2. Man, all right, my friends, I hope this is making sense. So the last part of section 7.3, which we'll talk about in the next set of videos, is going to be about partial fraction decomposition, which is what we're doing here, but special cases where the forms might be different. The process, though, will be the same. So as soon as you get good at this process, even if you have different forms thrown at you, you should be just fine.